Hi everyone, hope you're doing well. Today we are going to talk about Azure machine learning deployments. So basically what I did is few days back, I tried out deploying on Azure ML, one of the model that I had created on Kaggle. So I had done it in past, but I forgot most of the things about it, right? Now what I have done is while doing the deployment this time into the ACI, what I have done is I made a presentation containing all of the things that I normally forget and make the same mistakes again on the deployment side. So let me do one thing. Let me talk through the code first, which is used for ML deployment on Azure platform. And then probably we will come back to the presentation with the details about the mistakes and the useful things that you should remember while doing deployment on Azure ML. Let's go to the Azure ML workspace. So this is a sample workspace that I've created using my college ID, right? So as you can see here, Azure for students. I mean, Azure provides a free, not a free, but it gives $100 as a free token amount while you create a Azure ML or an Azure account using your college ID. That's what I've used. Now let's get to the code. So when we create a model, there are certain files that we end up creating while creating a machine learning model. The first thing that we do is we get all the data and then use the data to create a model, do all the pre-processing, go through the entire life cycle and end up with a model artifact. Not a single artifact, but there could be multiple artifacts that could come out of the entire training life cycle. Now, I won't get into the details of the pre-processing and all the steps which are done as a part of this use case of machine learning, because all the things are already available on Kaggle link. I will also provide the link to the use case of Kaggle on my description. So let's get started with an overall idea of the deployment. So first thing that we need to do is let's concentrate on the train file. So as you can see the structure on the left-hand side, I have created a taxi demand prediction folder. And then under that, I have created multiple folders. This is Azure ML, by the way, the workspace that you are seeing. So inside this, there are multiple notebooks. So the first thing is in source directory, you have EcoScore. So it is the inferencing notebook, which comes into picture when we are trying to do predictions or real-time predictions. There is also a training folder that contains a training file that is used to create the model or train the model and go through the entire training lifecycle. When we train the model, all the artifacts are stored here in this folder. We dump all these in this folder as well. And we also push them onto the registry, Azure registry as well, model registry. The data we have is a CSV file that we got from Kaggle again. Now we can also load the data into the data folder or the data assets as mentioned on the left pane. But for the sake of simplicity and because of some issues which I was getting while loading data into a data asset, I've just loaded the CSV directly here. So this was about the folder structure. Now let's get back to the code. The first piece, I've just removed the subscription ID of the Azure subscription that I'm using. So the first thing that we do is we create a technical workspace. To create the workspace variable, we need the subscription ID, the resource group that we have used to create this ML workspace, and the workspace name. So most of the places you would see my name because just for tracking, I've given MySpace as a dummy resource group name and workspace name. So here we create a workspace. Then rest of the steps are all about the machine learning model. So let me skip all of the steps wherein we are doing all the pre-processing on the data, trying out different models, and at the end, we dump all the models into the folder. So let me get back to the point where we dump all the model artifacts. So this is the point wherein we are dumping all the model artifacts into the model artifacts folder. Once we do that, all the data comes into model artifacts folder. So you can see all the three files that I utilized for the model training and for the pre-processing are present here. One is an encoder, one is a k-means clustering file, and then there is the final regressor model. Now, just to throw some light on the use case for the machine learning which I used here, this is a taxi demand prediction. So what we do is we provide the details like latitude, longitude, as well as the time of the day. And based on these three variables, we predict what would be the demand percentage in that area. So it could, for example, let's say you are in a city in, let's say, India. Let's say you are in Bangalore. Now in Bangalore, if we want to see the traffic percentage or the demand of the taxi in a specific area, then we would say this latitude and this longitude, what is the demand percentage of the cab Uber at this specific time? Let's say the peak time is 5 o'clock in the evening. So then it would give a percentage value, which will be the demand percentage of that area at a specific time for the cabs. Now, once I dump all the data, all the models, then I register the model artifacts into the model registry. What is the model registry? It is a service, or not a service, but a registry which is provided by Azure only, wherein once we are done with creating all the model artifacts, we dump them here. So let me take you to the model registry to show you where it goes. So here you can see the model registry, right? It has all the model artifacts. Few of the files got created by itself, like AML, ignore. These files I didn't create. The other 3 files, encoder, k-means, and taxi demand prediction model, these actually came out once I registered the model into the registry. Post that, we have the environment setup. So once we have registered the model into the registry, the next thing is, if you think about a generic deployment, what would be the ideal next step? You have the files with you, you have the model with you, you have the encoder files with you, you have all the model artifacts available somewhere. Then you would want to create a Docker file that could contain or containerize all of these stuffs like environment, configuration, and inference file. And then that Docker container can be pushed into any other system, which can then install the Docker image as a Docker instance, and then can do inferences using that specific machine. So all this process which we do of Dockerizing and creating an image, all of that is taken care by Azure ML automatically. But we need to provide the details which are required by the Docker container. For example, an environment for the inference, we require all the configuration and the location of the scoring file or the inference file. So the first thing is we provide the environment details. So the main thing to note here is it contains all the requirements or the requirement Python packages, right? So you can see here Python packages which are required are all these packages, which will be required by the inference files. I'm mentioning all of them. Then the configuration. So configuration would essentially mean where is the scoring file. So I'm just giving the location of the scoring file. Source directory is the folder, and then you have the score script, which you can see on the left-hand side. This is a folder, and then there is the echo score file. Now, before pushing this Dockerized container, this into a third party or a third machine for deployment, we would want to test this container locally as well. So in the next step, we have local deployment, wherein this Docker container is deployed locally. So when it is deployed locally, it is actually deployed on the instance or on the compute, which is used for doing the entire training. So if you can see here, I created a machine which is just a single node machine, a CPU based machine for training the model. So the same machine is going to be used for local deployment of the Docker container. And then we are going to use this local deployment for validation or for testing. So this is a step where we are testing locally. You can see localhost. That means we are testing the deployed model, which is deployed as a Docker container onto this compute instance, which is also used for training. We provide all the data points, which is the pickup latitude, longitude, and the date time. Using that, we get a demand percentage. That was the use case, right? Now, once we have deployed it locally, we would also want to deploy it on a third-party computer or a third-party machine or instance. So here we are using ACI. ACI is a serverless architecture which is provided by Azure. It's kind of a low-cost deployment method which is used mostly for the development and testing purposes. Now, if you see here, we are also providing it some of the configuration like number of cores, memory in GB. This was not provided when we were doing local deployment. The reason is when we were doing local deployment, we were deploying on top of this cluster, which is used for training, which is already created and running. And now we are deploying it on a ACI thing, which is more of a serverless architecture. That's why you see the requirement for the RAM, memory, etc., is also provided. And then we click on deploy, not click, but provide the command to deploy along with all the configuration for inference, etc. So once this is done, the model is deployed into an ACI instance. Once that is done, we are just validating whether the model is working fine, and the same output we get here as well. Now also just to look at the echo score file, which is the inference file, there is a specific way in which this file has to be written when it comes to Azure ML. You need to provide a init function. In the init function, you need to keep the name of the function as is. If you don't keep the name of this function and the run function as is, you're going to run into some errors, which will take a lot of time. So better is to keep the same function names. And then in the init function, I'm loading all the model artifacts. So if you can see here, I'm just loading the first model artifact, second model artifact, and third one. Once this is done, then there is a run function which does the inferencing and provides you the demand percentage. So this is a glance on the scoring file or the influencing file. Now that was about the overall code which I have written, or the overall structure of Azure ML when it comes to deploying some model, training a model, going through the entire training cycle, then loading the model, and then using it for inferencing in the local phase, and then deploying it into an ACI instance as well. Now, once this is done, let me also take you through the PPT, which contains some of the really important things, which I made sure to mention in the PPT so that I don't forget the next time I do this kind of deployment. One of the mistake that I did is the kernel which I have to use in the training file. So we need to use Python 3.10 SDK v2. If you don't use it, there will be some library issues. For example, I ran into an sklearn issue. When the kernel has to be provided, it has to be provided here actually. So if you go here, there is a drop down, you can select the kernel. I have selected 3.10 SDK v2. Once you're done with this, there are other multiple important things which I have mentioned. So I have stored the keys and resource keys and values, etc. in the notebook itself, but you should ideally store it in Key Vault if you're running a enterprise level or a production grade code. Then this is just mention about the storing of the model into the registry. I mean, here I'm pushing them to the registry. And the environment setup, I already spoke about the libraries which needs to be mentioned. The other library which I forgot while mentioning was Azure ML API SDK. This is also a key library that has to be mentioned because we are using Azure ML SDK, and that has to be mentioned as well as one of the requirements for deploying your model into a third-party environment or Dockerizing it. Then the other key things we've already spoke about those. And this is about the ACA, which is a serverless kind of an architecture used for low-cost deployments. There are other alternatives also. If you're doing a really high-end deployment, then you can go for Kubernetes. And for batch inferences, you can use Azure Compute itself. The other option is you can create a Docker container offline, and then you can use that container on top of Azure Cloud for deployment as well. So those are multiple options. Then it is just about the testing and some other issues that I faced. And some other key views also I mentioned. So within Azure UI, there are some other key views that are worth looking at. So one of them is models. I just took a screenshot of that. So when you register your model into registry, this is the kind of view you get. Then the endpoints view, so which shows you the endpoint when it is deployed into a remote ACI architecture. Then this shows the compute that I used for training and for the deployment locally. So this was the compute that I used. And that's pretty much all about it. Thank you so much. Have a great day ahead. See you next time.